So that's a very brief and very selective trip through the Western philosophy. We have definitions of causation as well in the East, and they are different, and that's very interesting how they differ from Western definitions. But all the definitions that we've seen so far are not very useful. They do not seem very practical. Can we do something about it? So there's one definition that I would like to propose for us for today, and it comes from Judea Pearl, and it refers to the idea that Jean shared with us a while ago. And the definition says, A is a cause of B if B listens to A. So that's a little bit metaphorical, maybe. So let's unpack it. Listens to here means that if we change something in B, we also expect that something, if we change something in A, because B listens to A, we expect that something in B will also change. Now, we can think about some special cases here and so on, but for the sake of today's presentation, we'll just keep this definition as it is. And an important aspect of this definition is that it is an interventional definition of causality, because listening to means a response to a change. So we need to act, or something in the world needs to act, needs to change, and then we observe a change in another variable. And those changes, we will refer to those changes as interventions. So interventions are important for causality, especially in the Pearlian framework. That's not the only framework that we have on the market. Some of you, I've seen somebody talking about econometrics here, or economics. So many people in economics will be familiar with so-called Rubin causal model, or the potential outcomes framework, which has also been expanded and extended by one of the creators of the Causal Discovery Challenge, Guido Imbens. But we will focus on the Pearlian view here, and I think for a good reason. So interventions are important in this framework. As a margin note, the potential outcomes framework is largely logically equivalent to Pearlian framework, so we can talk about the same stuff, just using slightly different language. But interventions are not the only thing in the Pearlian framework. And to talk about this in a way that is structured, we will use this idea of the ladder of causation. The ladder of causation it's not a one thing, it's many things. But one thing it's a great device to talk about different levels of relationships between variables in a way that is structured. But it is also it comes also with a mathematical framework, or a set of languages, different formal languages that describe those different ranks in this ladder. But let's do not go ahead of ourselves. So what is the ladder of causation? The ladder of causation is this device that has 3 different ranks, and each of the ranks describes a different level of relationship between variables. Associations are like correlation, but also when we think about correlation, it's good to define the term. We are not only thinking about linear correlations, we are also thinking about any other types of association. So if we have a measure theoretic metric, for instance, like, I don't know, something based on mutual information and so on, all of these things will be associations because they are based on the pattern in the data. They only look at the data and they say, okay, there is some pattern in this data. Then the second rank is the interventional rank. So this rank introduces the notion of acting in the world, doing something. Then the final rank is the counterfactual rank. The counterfactual rank is about minimal changes in the system. I'll give you a more concrete example here. So for instance, we might imagine a situation where some of us, maybe Max has a headache today, and Max takes some painkiller at, let's say, 1 hour, he had a headache and took a painkiller.
You're spying me, Alexander.
I hope you didn't have a headache, but if you had, I hope you don't have or won't have it soon. Anyway, so let's imagine that 1 hour ago, Max had a headache and he took a painkiller. Now, he doesn't have a headache anymore. But now, this doesn't mean that the painkiller was the cause that his headache disappeared, right? Maybe his headache disappeared just naturally, and the painkiller did not really affect it. So we could ask a counterfactual question, and this question would be: if Max had not taken the painkiller, would he have experienced headache right now? Right, so that's a counterfactual question. We often think about counterfactuals in terms of the past, looking into the past and saying, "Oh, if we changed something back then, what would be the reality now?" But but counterfactuals are not limited to the past. We can also think about counterfactuals in the future. So we say, "Oh, that will be some future state of the system. If we will change something in the system, what will be the state of the system at time t plus some I, t plus I." So counterfactuals, we can also think about counterfactuals as a ingredient of interventions in a sense. So interventional distributions. But I don't want to make it too complicated. So before we move forward, I also want to give you another perspective on the ladder of causation. Associations are related to the action of observing. Interventions are related to taking actions, interventions, intervening in the world, acting in the world. Counterfactuals are related to the action of imagining. So that would be, if we think about counterfactuals, that would be thinking about scientific theories, for instance, building structural causal models, building a theoretical representation of some notion. So I hope this this sounds clear, but I want to stop here for just a second and ask if you have any questions regarding this, because these concepts will be important for us. So if anything was not clear, I'll be very happy to clarify this for you now.
Yeah, let's check the chat. I think it's quite interesting. I even see Royston saying that he's now interested in a ML master degree, thanks to you. So yeah, it's top quality, Alexander. Yeah, definitely. Thanks for bringing all of those concepts to our community. I'm checking the chat. I don't think anyone has a question. It seems like very clear and all clear for everyone. So maybe we can move forward. Oh, no, that's a question. What makes an imaginary theory one that we, I guess, do not yet know is true, quote unquote, counterfactual? I'm not sure that I understand the question, but maybe, Alexander, you got it?
What makes an imaginary theory one that we, I guess, do not yet know is true? Okay. So counterfactuals, we won't have time to go into the math behind counterfactuals, but this is a very well-defined concept mathematically. So it's less about the theory being imaginary. It's more about the idea of computing different outputs from a system, given that we change just one thing or maybe a couple of things, but let's stick to one thing, just one small thing. So you can think about this in terms of, for instance, maybe you have a degree, I don't know, you have a degree in economics, right? And you are somewhere in your life. And now you are wondering what my life would be if I did computer science instead of economics, right? So that would be a counterfactual question. But we want to keep everything else constant in this counterfactual world, this imaginary world. So, like your girlfriend or boyfriend, they would be the same, right? And your relationship with your parents and so on and so on. We only change this this one thing, your degree. And we see how this propagates in the system, which is your life here in this case, how it propagates and to what outputs it leads us. And now you could you could say like, oh, okay, that might be difficult because we would need to capture a lot of detail, record a lot of